So what we had here is we had these huge, ice continents. And when they melted, and they melted fast, they created such momentum. I mean, and then the ice broke. The ice continent just broke into pieces. It just kept breaking, creating even more momentum and more waves in the water. And the water just rose in areas really quick, and tsunamis literally just wiping out entire marshes, and it just kept happening. And then the ice, with such momentum, ripped through the land and got stuck in rivers, got stuck in lowlands where there's like mountain edges or hill edges or all kinds of things like that, where they just got stuck. The huge pieces got stuck, sure, closer, not as far, didn't go as far up, but some of them did, and they just literally ripped through the land and left marks everywhere, all over the earth pretty much, except, in the mountains, which was kind of hard. But even then, when the waters rose to the height of the mountains, some ice did, in fact, end up in some areas, in lowlands of the mountains, So you have the effect of even these huge pieces of ice, just pummeling through all kinds of things, all kinds of land, and then depositing all the metals or all the rocks and all the chemicals and everything that was on the ice continent originally. So you can even tell which piece belonged to which continent, which ice continent, by knowing that they have different chemical contents, different heavy metals coming from those volcanoes into the ice. And it's really interesting, though, because you have the ice, and it's attached to a lot of the mountains, and, attached to the land. So you do have some really interesting effects of the volcanoes there, too. Whatever volcanoes are closer to the edge, and, generally the middle of the ice continent is not necessarily right smack dab in the middle, because the ice spreads out further into the sea, and it's kind of edged out and blocked by the mountains and the hill and the land near the mountains in the back. This is the North Pole, near the Rocky Mountains and the Alaskan Mountains, where the glaciers would just spread down into. So you have these volcanoes in those areas, but they would literally just push right into the ice, because it's easier to melt through the ice than it is to push through tons of rock and tons of, dirt and rubble, whatever. Well, I don't know about rubble, but dirt and rock, and just basically harder to push through that. So that's the whole point. Maybe the rubble thing, I'm having that in the mind, since I keep thinking of those huge ice pieces, just these ice chunks just pummeling through all over the world, literally making rubble out of trees and rock and everything, and land, just literally pummeling through and destroying it completely. So you have that effect, and it's actually very, very visible. So, well, on the ice poles, the ice continents themselves, you do have that effect where the volcanoes that are even near the edges or near the mountains of Antarctica in the South Pole, and the North Pole, it's the British Columbian and Alaskan, the Rocky Mountains. Well, what happens is that, like I said, it just the lava and the volcanoes, they just push through the ice a lot easier. So you really do have a lot of volcanic action on the ice continents themselves, more than anywhere else in the world. And when that water rose, and it rose quick, it created volcanoes on land, it created massive earthquakes, because now you have all this pressure of the water pushing down and pushing on the land and on the crust, and it's literally pushing these volcanoes even higher up, into the land. and they don't have the option of all that pressure and ice there, so those volcanoes literally die down, and then the others blow all over the place. And they're huge volcanoes blowing and huge earthquakes. It was the most disastrous thing to ever happen to the Earth. And it changed everything. And we're lucky that the planet didn't hurl into the sun. I mean, seriously, the gravity changed, because now we had less gravitational pull of our own. The Earth is actually turning slower. So, I mean, and the moon, we're lucky the moon didn't fall into the Earth. Also, I mean, it got closer as well. It got further. No, it got closer. That's what happened. Because, yeah, the gravity. The Earth, the sun, the moon was closer to the sun in retrospective, but when the Earth moved, it changed the orbit of the moon itself, because the pull of the Earth is less, because there's more the gravity is more centered. So what happens when it slows down is that it moves towards the sun. So if the poles, well, they're gonna melt. They're melting. We already know they're melting. The Earth is dying. There's no doubt. And once those poles melt, if they don't form in the right place, we're done. I mean, there's no way to survive that. I mean, if there's more water again that ends up on Earth, and that the poles become larger, we're done. We're gonna go hurling into the sun.